In this video, we are going to look at the synthesis of naphthalene. Now, if you are new here, please take a second or two, then subscribe and like and share the video. And for the subscribers, I want to continue thanking you guys for the support that you are offering. Now, today we are going to look at the synthesis of naphthalenes, and somebody may ask you, what are naphthalenes? Naphthalene, in simple terms, simply means two-fused benzene ring. And for the synthesis of naphthalene, we are going to go through three basic steps. And for the first step, it's called EAS, or simply means electrophilic aromatic substitution. And in this step one, we are going to use a benzene ring, and we are advised actually to use a more derivatized ring. So definitely we might go for phenol or chlorobenzenes. And for the step two, we are going to look at now the ring closure. Then the last step, which is our step three, shall be the aromatization of the ring formed. Now, let's start. For the whole process, for us, we opted for phenol as our more derivatized ring. So this is a phenol, and we are going to use succinic anhydride. So we are going to react phenol and succinic anhydride. So we shall start. This is succinic anhydride. So we are going to react this. This ring shall attack the carbonyl, and then this bond shall open up so that we can have, this is EAS now, electrophilic aromatic substitution. So we shall have our aluminum chloride there as our catalyst. This is Friedel Craft acylation. Now, this is the Friedel Craft acylation. So after the ring attacking the carbonyl, this bond shall open up so that we shall end up having, this is our ring. So after this ring of succinic anhydride opening up, so we shall end up this phenol combining with this opened up ring to form this compound here. So after forming this compound, we are now going to carry out the reduction process, the Clemmensen reduction. So, and our reagent shall be zinc amalgam, or rather amalgamated zinc, in presence of hydrochloric acid, so that it shall remove this oxygen here, so that we end up having our compound ash. Our product shall be this OH here, and then we shall have it this way. So you realize that this oxygen left, so we are left with this. That's why we are having only one oxygen there. So after arriving here, we are going to conduct what is called the ring closure. So you realize that this is an open ring. So we are going to carry out ring closure. And ring closure, we are going to carry it out in presence using HF. This is hydrofluoric acid in presence of heat, so that this hydrofluoric acid shall donate the hydrogen into this hydroxyl group here, so that it forms water. So let us see how the water is formed here. So now this is our formed water. We realize that water is H2O, so we are having our 2H and oxygen. So water is known to be a good living group, so it shall live. So we are going to have water out. So this is minus water, so that we can have this, what shall be our product here after the ring closure. So this is what we have after the ring closure. Actually, we had our there. Our oxygen was there. You realize we had one oxygen here, so the same oxygen is here and the same oxygen is here. So after carrying out the ring closure, so we shall end up having this our product. So after having this as our product, we're going to carry out what is called Wolff-Kishner reduction process. So definitely reduction. And Wolff-Kishner reduction process, it's carried out in presence of hydrazine in presence of basic condition. You can choose to use sodium hydroxide as your base there, so that it will reduce and eliminate this oxygen that is there, so that we can have our product as this. Now becomes our product after conducting the Wolff-Kishner reduction process. Realize that the O shall leave, so that we end up having this. And this is now our step 2. So we are left with one final step, which is step 3, and we called it aromatization. So you realize that this ring, it is aromatic, but this ring is not aromatic. So we conduct aromatization using palladium, but in presence of heat. So using palladium in presence of heat, we shall have this is what is going to be formed after carrying out aromatization. We had our OH there. So after aromatization, this ring shall be donated with pi electrons. So this now becomes our final product after aromatization. This is now the naphthalene. And to be precise, we have our OH here. This one becomes 1, 2, 3, 4, 5, 6, 7, 8. This one becomes 8 after all. This becomes our final product. Thank you for watching.